Hello everyone, welcome to our class. Today we will talk about the zombie process. What's the zombie process? Where they come from? Why we get this zombie process? And how to kill zombie process in your system, in your program. So let's look at the zombie process. Okay, so this is the source code we have. So inside the source code we have a fork. The fork generates a new process, a child process. Also, it's return 0 means the child process. If this process is child process is return 0. So if this equals 0, you go to the child part. Otherwise, you go to a parent part. Okay. So inside the child process, the child prints something and finish. But the parent process do a while loop. So which means the parent process is always running, like a keep running, do not stop. So in this case, actually, it's called the child process. Why is it called child process? This child process becomes zombie. Why? Imagine that you give a birth of a child, and after you give a birth of a child, you don't care this child anymore. You don't care about the child. You just like keep working for your job, for your hobby, for your anything. You just don't care the child, and the child is just going to die because the child maybe just no one care about it, and child just do something and finish. The child dies lonely. If the child dies lonely, the child becomes zombie. So this is very like a simple example to talk about why child becomes zombie, because the parent doesn't care. The parent doesn't care the child. The child is die zombie, so becomes zombie. Okay, so this is the kind of the first idea why we get the zombie process. If the child process finish, the parent process does not finish, and the parent process does not check with child, then the child will always be there as a zombie process. So in other way, if we have a reverse way, we still have a child. This is fork equals 0, this is child, this is parent. But right now, the parent finish immediately, and the child just do something like for all the time. So in this case, do we still get the child process, a zombie process? No, we don't get zombie process. Why? Because the child is grow up, the parent is die, but parents see the child process. Okay, you are grow up, you do a lot of stuff by yourself. I'm so proud of you, so I don't need to worry about you. I die with peace. So in this case, the parent process won't need to take care of the child process because the parent process believe the child process can do anything by itself. So in systems, actually, if your parent process is die before your child process, it won't create any zombie process. So summary, why we get the child process? Where they from? So the first condition is the child is dead. The second condition, parent is not dead. So if your parent is dead before a child, then it's okay. There's no child process. There's no zombie child process. Okay. So if the child is dead and parent is not dead, and parent doesn't care, parent don't care, we will talk about what means care here. We will talk about it later. So parent don't care, child is dead, parent is not dead, then it's created zombie process. It's need all these three conditions happens, then it's created child process. Either one not happen, won't create the child process, zombie process. Okay, so all these three conditions should happen, then you get zombie process. Otherwise, no. For example, in this case, even though the child process still doing something, but because your parent process is already dead, so the child process never become a zombie in this example. Okay? So actually, for this case, we have another keyword for the child process. What's a child process? In this case, if a parent is dead first, the child process will become an orphan or run away process. So actually, we give another keyword for this process. but this is okay. If you have a runaway process, totally fine. But if you have a zombie process, this is not good. This is definitely not good. And why this is not good? Because it's occupied the resource in your system. I will show you an example. I will show you the code to see what happens if you have a zombie process in your system. Okay, so let's see this example. This example, inside this example, we have a fork. So we use fork to generate another child process. And we use the return value. If the return value of fork is 0, means it's child process. If it's non-zero, means your parent. So if this is parent, I try to get the parent's process ID and the child process ID and do an infinite loop. So which means your parent is always running, not stop, okay? And for your child process, it's just print something and finish. This will create the zombie process because the child is dead and parent is not dead. And parent doesn't care about child. So in this source code, if we do GCC, then we run it, we can see we got the parent process ID with 2217 and child process ID is 2218. Okay, so let's look at the our system. In this case, actually the process ID, the child process ID should be finished because it's print out something, then just return finish, right? But inside the process, inside the system, you can still see this process in your system. So which means this program should be finished. This process should finish. It just print out something and finish, but it still occupies the resource in your systems as a zombie process. Okay, so it's still here. It's still here, even though it don't do anything. There's no task, there's no job this process need to do, but it still occupied your process ID. It's occupied resource for this process. So this is definitely not good. This is zombie process. So we need to figure out a way to kill it. Okay. Okay, so this is one example about the zombie process. Let's see another one. If we have the while loop inside the parent process, what happened for this? Okay, so let's look at. So we do a GCC again with fork. So you can see the child process is 48, parent process is 47. Okay, so for this one, the parent process after it print something, it should be finished. Let's look at. You can see actually we only got this fork, and this fork is child. The ID is 48, not 47. So actually the 47 is disappeared. So this is totally okay. This new child process, the child process become orphan, become runaway process, but this is fine because the parent process won't occupy the resource we have. Okay, so this is the example showing the difference between the child process become zombie or child process become orphan. Actually, it's give our system like a totally different story to manage. Okay, so here's the question: how we kill a zombie? How to kill a zombie? The zombie is not good. How to like avoid the zombie process? So do remember there's a 3 conditions for zombie process. The first one, P is not dead. So the parent process is still alive. Child process is dead. Third one, parents don't care the child. Okay, don't care the child. So for these 2, we cannot control everything, but we can do something like this. We can care the child. Care. So how to care a child? So the way to kill a zombie, how to kill a zombie is we use these either one, these 2 system code to wait. If your parents wait for your child, the parents kill the child. So the child won't become a zombie, okay? So this is an example how you rip a zombie. The way to rip a zombie is use wait system code. So how to write the wait system code? You can see the example here. We just use a wait here, try to use a wait and pass some variable, this integer variable, we pass this address into the wait. So in this case, when your child process finish, it will return some value, tell your parents what's the return, what's the finished state, what's the complete state. what's the return value, for like general return value for a whole program. Okay, so you can use wait to get this information into a variable, and because you care this child process, so the child process never become a zombie. Okay, so this is a way how to rape a child. So let's see the example in our ED lab machine to see, do we actually kill the child, kill the zombie child process? Okay, so let's look at this example. This example shows a zombie process. So how we generate a zombie process? We use fork. And if fork return non-zero, which means it's parent, and the parent do infinite loop, which is run forever, okay? And your child process print something and finish. So it definitely can create a zombie process. This is an example we showed before, like a couple minutes ago. Okay, so let's see how we reap the zombie. So actually, this is not so hard. We can just put wait here, make your parent wait for a child. And if you don't care the return at like a status of your child process, you can just put null here. So for this one, you can actually reap the zombie. You can kill the zombie. So let's see how it works. Okay. So right now, we can do GCC, and we run a fork. So we run a fork. So you can see we got the child process ID, which is 81, and parent process is 80. So in this case, your parent process run forever, but it's okay if it's actually reap the child process, the zombie process. We should see the 81 disappear in our system, right? So let's see, is still in our system or not? Actually, you can see there's only one fork, which is 80, the parent process, because it's run forever. For the 81, it's already disappeared. So there's no zombie process in this case because your parent process care. Your parent process care the child. So the child won't become zombie. Okay? So I hope you got like what's the zombie process and why we get zombie process, how to kill the zombie process in this lecture. So I think the story is that just don't forget your child. If you create if you use your program to create child process, make sure the child process don't become zombie, because if it's become zombie, it will occupy our system's resource, right? So again, if you in the future, if you are a parent, if you have a children, please take care of your children. So don't leave them alone. Okay. So if they like die lonely, they probably will become zombie. Okay, so I hope you today enjoy today's video. See you next time. The zombie process is